Lesson 31, using ratios and proportions. A ratio is a comparison of two quantities using division. So, for example, they give us 2 boys to 3 girls. We can write this any of these 3 ways and it still means the same thing. A rate is a ratio that compares quantities measured in different units. So, for example, if I had 5 feet per 30 seconds, or 15 apples for $6, I am comparing quantities, these quantities of 5 and 30, and then different units, because this is 5 feet and this is 30 seconds. The same is true for 15 and 6, those are 2 quantities, and the different units would be apples and dollars. A unit rate is a rate where the denominator is 1. And a unit price is a cost per unit. Okay, so for example, 55 miles per hour, the denominator is 1 hour. We know that already from doing some of our unit conversions. And $2.50 per box, $2.50 per box. It could also be per ounce, per can, whatever it is. So it says, which is a better buy? 10 bananas for $1.35 or 8 bananas for $1.20. So what you need to figure out is, it's hard to do it just by looking at it, because 10 bananas is more, but so is $1.35. So we have to know how much we're paying per banana. That's what I want to know. So I want to know dollars per banana, and I'm having to use my keyboard to write because my tab isn't working right now for whatever reason. So excuse the clicking, I know it's annoying. So I'm going to plug in the numbers that I have. The first one is $1.35. For 10 bananas. So if I reduce this to a price per banana, let me get my calculator out here. Actually, I really should need it because it's 10. So this would be the same as 13.5 cents per banana. Okay, this is my per banana there. The other one is $1.20 for 8 bananas. So when I divide 120 divided by 8, that is 15 cents per banana. So we want to know which one is the better buy. Well, the better buy is the one where you're paying a cheaper amount per banana that you're buying. So the better buy would be the first one, the 10 bananas for $1.35, which is 13.5 cents per banana. Example 2, a car travels at 60 miles per hour. How many miles per minute is this? We've already been practicing these sorts of things. If we have 60 miles per hour means 1 hour. The fraction bar means per for us here. We want to know how many miles per minute this is. Well, we don't want to change miles, we want to change hours. We know that we're going to have to multiply. And we want to cancel hours, so hours goes in the top. Minutes goes in the bottom. Okay, so my equivalency is 1 hour is 60 minutes. So hours and hours cancel, and then I'm left with 60 miles per 60 minutes, which is just 1 mile per minute. Okay. Here it is. A hose sprays water at a rate of 10 gallons per minute. How many quarts per second is this? So we know that we're dealing initially with 10 gallons. And that is, it's spraying at 10 gallons per 1 minute. So we want to convert it to quarts per second. That means we're changing both. So let's change gallons first. For gallons to cancel, it must go in the bottom. And I'm changing it to quarts. And the equivalency between gallons and quarts is that there are 4 quarts in 1 gallon, and I have to multiply again because these will cancel right now, but whenever I multiply across now, I'm going to have quarts per minute, but I want quarts per second. So minutes is what cancels here. And on the bottom is going to be seconds, because that's what I'm converting to. And I know that my equivalency between minutes and seconds is that for 1 minute, there is 60 seconds. Minutes and minutes will cancel. So I have 40 quarts per 60 seconds. And that would reduce to 2 quarts over 3 seconds. Okay, but if it wants to know quarts per second, it wants it as a unit rate, so I need this to be a 1, so it's just going to be 2/3 of a quart per second. I again apologize about the clicking and about my handwriting. A proportion is an equation that shows two ratios are equal. You start working with proportions with Mr. Spears, and I know that he is a rock star when it comes to proportions because everyone comes out of 6th grade knowing how to do proportions. To solve a proportion, we must do the cross product, that is A times B equals B times C. And so to do this, A times B equals B times C, we're going to go ahead and show X times 4 equals 3 times 24. So X times 4 gets me 4X. And 3 times 24 gets me 72. To get X by itself, I need to divide by 4. So I'm left with X equals 18. Okay, on B, it's the same thing. We're taking A times B equals B times C, but we have to take this whole quantity for A. So when I show my multiplication, it's going to be 30 times that quantity of X plus 1. And that has to be equal to 15 times 8. At this point, I want you to pause and try and simplify this on your own paper. Okay, so whenever we do this, I have 30, which I have to distribute to everything on the inside. I wish my pen was working right, because this is very difficult to do. Stop. Clicking. Stop. So I have 30 times X, which is 30X. Plus 30 times 1, which is 30, equals 15 times 8, which is 120. And now I'm solving to get X by itself. So I need to subtract 30 from both sides of the equal sign. Whoops, I just put division and I should not have. So I'm subtracting by 30 on both sides. That will cancel, leaving me with 30X equals 90. And to get X by itself, again, I must move that 30, and to do that I'm going to have to divide because it's originally being multiplied. I must do the opposite. So I end up with X equals 3. The ratio of pencils to erasers is 1 to 2. There are 24 pencils and erasers in all. How many pencils and erasers are there? So first of all, I know that I'm talking about pencils, erasers, and the total. Pet. That just happened to happen. Pencils, we know, is 1 to 2. The total is going to be when we add these. So that would be 1 plus 2 is 3. And then we have that 24 pencil. There are 24 pencils and erasers in all. So that means the total is 24. I don't know how many pencils or how many erasers there are right now, but using this information you should be able to set up a proportion to solve that. So how many pencils and erasers are there? Set up this proportion right here. So I have 2/3 equals t over 24, and I want you to go ahead and solve that on your own. Once you find out how many erasers there are, then you need to find out how many pencils there are. Final example, Susan ran 12 miles in 2 hours during training. If she runs at a constant speed, how long will it take her to complete a marathon that is 26.2 miles? So I know that she can run 12 miles in 2 hours. And I want to know how long it's going to take her to run 26.2 miles. Well, I want to put that in the same location as wherever it is over here. Miles is on top here, so I'm going to put the miles on top over here. If I mix those up, it will ruin my answer. So that's over x because we don't know how long. And at this point, I want you to go ahead and solve and figure out how long it's going to take to run that 26.2 miles. Make sure that you've taken good notes, and I will see you in class tomorrow. Lesson 32, Simplifying and Evaluating Expressions with Integer and Zero Exponents. An algebraic expression may contain exponents that are positive, negative, or zero. So, here we're talking about powers of 2. So we have 2 to the 4th power is equal to 16. Let me get my pen out here. Okay, 2 to the 4th power, we know means 2 times 2 times 2 times 2, 2 4 times, and that gets us 16. 2 to the 3rd power gets us 8, so we have 2 times 2 times 2 gets us 8. 2 times 2, we know is 2, or 2 to the 2nd, excuse me, is 4, and 2 to the 1st is 2, but it says what are the next 3 powers? Well, what's happening from 16 to 8? We're dividing by 2. No, that's not like it's supposed to. From 8 to 4, we're dividing by 2. From 4 to 2, we're dividing by 2. So the pattern, you would think, would continue, or at least I hope you do. So if we had 2 to the power of 0, because we're going down 1 in powers each time, we hopefully already know that anything raised to the power of 0 is always equal to 1. Here we're taking 2 divided by 2, and that is, whoops, going to get us that 1. Okay, so next, that's our first power. So the next power, if we're going down 1 for our powers each time, is going to be 2 to the negative 1. Well, what's that going to equal? If I'm dividing by 2 each time here, 1 divided by 2 would give me 1/2, right? One more time, we have 2 to the negative 2nd power, because we're going down by 1 each time, equals, and if we took half of 2, we're dividing by 2, half of 1/2, I didn't mean to say 2, half of a half, that's going to give me 1/4. This, remember, is the same as dividing by 2, because 2 is over 1, so I could flip it and multiply. That's where I got that from. So these would be the next 3 powers. 2 to the 0 and anything to the 0 is equal to 1. 2 to the negative 1st is equal to 1 over 2. And 2 to the negative 2nd is equal to 1 over 4. So this is the rule for negative exponents, and that is x to the negative n equals 1 over x to the n, and x to the n equals 1 over x to the negative n. What they're saying here is that you can take this negative exponent and make it positive by taking the negative exponent with its base to the opposite side of the fraction bar. Okay, so here when we moved it down, that's what happened here. It became a positive. which left us with that 1 on top. Over here, it was already a positive, so when we moved it down, we took it and we moved it across that fraction bar, it changed the sign. So instead of being a positive, it became a negative. The 0 exponent rule is that x to the 0 is equal to 1. We already said that anything raised to the power of 0 is equal to 1. So it says simplify each expression. It's wanting us to write these with a positive exponent. So I know that this is understood over 1. And this negative 9 I make positive by taking the negative 9 I can make positive by taking that negative exponent with its base and moving it across the fraction bar. When I do that, I'm left with 1 on top and x to the, instead of a negative 9, it will now be a positive 9. Final answer. On problem B, I have d to the negative 2 over c to the third. The only thing that I need to simplify here is the negative exponent. I need to make it a positive. So to make this negative 2 positive, I'm going to take the negative exponent and its base, and I'm going to move it to the opposite side of the fraction bar. When I do that, again, I'm left with 1 on top over c to the third stays because it was already there. And that d to the negative second becomes d to the positive second. Final answer. I would like for you to pause the video and try to do this one on your own. On c, my negative exponent is in the denominator. So I'm going to take the negative exponent with its base and I'm going to move it up across that fraction bar. When I do that, on top I technically have 1 times a, and instead of negative 5, I will then have a positive 5 over 1. Well, I don't have to show this 1 times, and I don't have to show the 1 on the bottom either. So my final answer here would just be a to the 5th power. Final answer. It says evaluate each expression for a equals negative 7 and b equals negative 4. So I hope that you remember that whenever I'm substituting for a variable, I always use parentheses. So instead of a, I'm going to substitute negative 7. That's being raised to the 0 power. And b is negative 4. And that's being raised to the 2nd power. Okay? So to simplify this, I need to actually find what those exponents make my bases equal to. So I hope that you remember that negative 7 to the 0, or anything to the 0 power, is going to be just 1. So this is 1 times negative 4 squared means negative 4 times itself 2 times. I just wrote a 2 instead of a 4. Sorry about that. Negative 4 times itself 2 times because of that exponent of 2. So now what I have is 1 times negative 4 is negative 4. Negative 4 times negative 4 is a positive 16. Final answer. On the next one, we're doing the exact same thing. So I have 8, and instead of b, I'm going to plug in negative 4, which is being raised to the negative, to the negative 2nd power, times b, which again is negative 4, and it's being raised to the 1st power. This is multiplication, it looks like a minus. There we go. Okay, so the first thing that I need to do is follow my order of operations. An order of operation tells me that I have to do parentheses first, and I can't simplify anything inside of these 2 sets of parentheses. So next on my list of order of operations is exponents. So I need to simplify these exponents. When I have a negative exponent, I can't simplify it until it becomes a positive. So I'm going to have to put this whole thing over 1. And this negative 2 I can make positive by taking it and its base. The negative 2 only applies to this negative 4 here. And I'm going to move it across that fraction bar. And then I should already know that negative 4 to the first power is just going to give me negative 4. So on top, I'm left with 8 times negative 4 over, this moved down, remember, so it's 1. I don't need to show that anymore because it's 1 times this, which is going to be negative 4. And instead of the negative 2, it is now going to be the positive 2. So on top, 8 times negative 4 is negative 32. On the bottom, I have negative 4 times negative 4, which is going to give me a positive 16. Negative 32 divided by 16 gives me a negative 2. Final answer. So the quotient rule for exponents says that if m and n are real numbers and x isn't 0, then x to the m over x to the n equals xm minus n, which is equal to 1 over n minus m. So what they're saying is, normally we know that whenever we're dividing with the same base, we subtract the exponents. But I can also subtract by bringing this one down. And whenever I do that, I'm going to be subtracting whatever it is. That's where they got this, because up here will now be a 1. So they want us to simplify each expression. And what I need to remember is that when I simplify, I always want to have positive exponents. Unless the directions for some reason tell me to have negatives, I always want to have positive exponents. So here I have x to the 9 and x to the 6. Those are both positive, but it's not simplified because I have a base of x on the top and on the bottom. So to change that, I'm going to have to do my quotient rule for exponents. And since they're both positive, I'm just going to do this like normal, especially because this 9 has a greater absolute value. So I want to subtract 6 from 9. That will keep it positive. So this is going to come up, which is going to give me x to the 9th minus the 6th, which gives me x to the 3rd. Final answer. On this one, the same thing is happening, but on this one I have a negative, and I want to change that negative to a positive. So to do that, I'm taking this one and I'm bringing it up here. Now, I'm going to show you this in two different ways. First is the quotient rule, which says that if I have x to the 9th, then I'm going to subtract whatever this is. So this is a negative 6. And minus a negative gives me a positive, so that would give me x to the 15th. I could also do it the way that we were doing it earlier by just making that 6 a positive first. So when I move it up, I would have x to the 9th times that x to the 6th, because it would be positive instead of negative. And we should remember that when we're multiplying by the same base, we add the exponents, which would get us right back to that original answer. On this one, I'm going to move anything that I need to make sure that my exponents are positive in the end. So here, this x is raised to what power? If we don't show a power, we know that it is automatically understood to be a 1. So I have x to a positive 1 and x to a negative 4. That means that I want to move the negative up. And I have x to the negative 6th and x to the negative 5th. Whenever I have negatives like this, I want to move the one that has the largest absolute value so that I end up with a positive. So between negative 6 and negative 5, the larger absolute value is that negative 6, so I'm going to move it down. And then I have z to the negative 3rd over z to the 1st. I hope you remembered that. This one's a positive, this one's a negative. I want to move the negative, so I'm moving it down. So what's on top? This x to the 1st, I didn't move it. It was still there. And when I move this, I'm going to follow my quotient rule, which means I'm going to subtract that negative 4, which is the same as just adding 4. So on top, I have x to the 1 plus 4 is 5. On the bottom, I have y to the negative 5th minus the one that I'm moving, which is negative 6. Negative 5 minus a negative gives me a positive. So on the bottom for y to the negative 5th plus the 6 gives me y to the 1st, or just y. And then I have z to the 1st, which was already down here, minus what I'm moving, which is that negative 3, which is giving me a double negative, so a positive. So I have z to the 1st plus the 3rd gives me z to the 4th. Final answer. A kilometer is 10 to the 3rd meters, and a millimeter is 10 to the negative 3rd meters. How many times larger is a kilometer than a millimeter? Express the answer in exponential and standard form. I would like for you to try to do this one on your own paper, and make sure you have your notes for class tomorrow. Have a good night.